Okay, everybody, welcome to, I don't know, is this the last session of the day? Almost last session of the day? Not the last, okay. So there's still a little more fun to come. But I figured we'd do a little quiz time to break up the monotony of the day. It's been a lot of sessions, I'm sure, in your rearview mirrors. So just to show for how many folks is this your first KubeCon? Oh yeah, that's amazing. That's a lot of hands. We're talking like, I don't know, 75% of the room. That's amazing. Okay, so again, I'm guessing everybody knows what this means. Right, okay, this Kubernetes, right? I mean, you know, it's a fair question, I think. Okay, then how many people know what the 8 means? Okay, it is not universal. I'm going to call on one of the people that knows, so keep them up. All right, okay, actually, you're willing to do it, so I'm not going to call on you. You see, that's the trick. Yeah, fine. But for the folks that don't know, so you're kind of going to get, it's your first KubeCon, you're getting into the Kubernetes ecosystem, and you should know how these things work a little bit, right? So, yeah, you got a K, you got 8 letters, and then you got an S, K8S. Works really nice, right? That's a little, maybe it's a numeronym. I don't know if that's a real word, but I think, you know, it sounds kind of like a word that could relate to this. There's some other fun ones that you might encounter along the way. Who knows I-18N? Blurt it out if you got it. Internationalization. Do you spell it with a Z or an S? Works either way. Doesn't care. Same thing. L10N. Go for it. Localization, I heard, yes. Same thing, S or Z, I don't care. S or Z, I don't know. A11Y. Anyone know this one? This one's super fun because I love it's like ally. Accessibility, exactly. And if you're in the venture capital realm, any VCs in the room? Any VCs? Okay, A16Z. Andreessen Horowitz, okay? It's even like leaked into the name of that business there. Okay, just a couple more, just because now, okay, people are getting the feel for this now. Okay, now you got the 8 figured out. How about K3S? Anybody? Come on, it's actually, you should know this. This is a CNCF sandbox project at this point. K3S.io, it's a lightweight Kubernetes from the Rancher folks originally, and everyone know why it's a 3? Yeah, okay, it looks like an 8. Yeah, it's so lightweight, you could just cut that 8 in half, and there you got your K3S. Yeah. Okay, two more, just because it's too much fun. Okay, K7S and K9S. You're really getting the indoctrination, the new folks here, right? K7S, K9S. Well, that's obvious. Everyone knows these. These are like, you don't have to be an expert in cloud native to know these, okay? God. But I mean, K9S is actually, there is something. Anybody a fan? Yes, K9S is also got the nail polish. It's a real pretty dashboard for your Kubernetes clusters. You should check it out for sure. Okay, well, before we dive in, I'll just stop for a second and say, hey, I'm Jeremy Adams. I'm a dev advocate at Neo4j. We're a graph everything company, probably best known graph database out there. And if you haven't really gotten into that area, either we're used for things like fraud detection, generative AI, real-time recommendations. You pretty much, if you shopped on Amazon, there's some graphs going on happening in the background, or on Facebook, or Instagram, or whatever, social networks, supply chains, all that sort of thing. And there's a couple of cool papers about also medical applications for things like cancer research, drug discovery, and also NASA thinking about going to Mars. So check it out if you're interested. Oh, I guess there was one more. We had Ally, so might as well do O11Y, which is observability. We got Ollie, observability. Okay, cool. So so think about this. 6 months ago, I put in the CFP. I mean, 6 months in like AI time, I mean, this is crazy, right? What was I thinking? So I'm like, I put in this CFP with this title, The Future Debugging is No Debugging. Observability is Dead. sounds really dramatic. And I was like, after this got accepted and then like some more time passed, I was like, what am I doing? This is crazy. So I was like, well, maybe I could just like switch out that first slide, and put something else. And then, so maybe I just say like, observability is dead. Long live observability for AI, right? It's more like, yeah. And then, but some other people might also find that sort of inflammatory that I'm talking about observability. Who's the real like observability people in the room? Okay, you're outnumbered, so it's okay. So I don't think you're gonna get too mad at me. And if you do, I've got backup. So then I was like, okay, maybe we need one more title here. And this one sounds really, I don't know, pragmatic. It sounds very like maybe you actually leave with some valuable practical lessons after attending my talk, other than knowing what K8S really is. But we're gonna talk about a little bit about this, right? Is there a time when you could just stop debugging and just rebuild instead? Well, here's the agenda in any case. I'm going to probably touch on all those different titles. They will haunt us throughout this presentation, some form or other of those titles. But this rough abstract should keep us kind of in the ballpark of the original abstract and maybe bring it a little up to date, because so much has happened in the last 6 months, and it just always does. So I'm going to talk a little bit about debugging and the observability paradox, right? Are we just getting too much of the wrong stuff, and is there something we can do about it? Also, understanding the toolbox that you might need for working with different kinds of code, right? And we'll talk a little bit about what kinds of code you might want to be considering and how they're different. And then we'll also talk about rewriting, that whole idea. Could we just rewrite things? What would that even look like? So diving in, everybody love debugging? It's the best, right? It's so funny to watch people debugging. I mean, it's so funny. I mean, unless it's you who's doing the debugging or someone you really care about, then it's not really fun at all. And this state of affairs right here is really just exacerbated by anything to do with AI coding assistance, vibe coding, whatever. It's just generating stuff. We don't know. We know maybe it works, and we're like, we don't know why it works, or we don't know why it doesn't work. And we're getting a lot of slop that we're dealing with on a daily basis. But there is debugging that we can do when things aren't working the way we expect them to. And we think we've all been here as well. I think AI can help us in some of these scenarios. If you've actually intended to write something, you did your best, you've got some structure to it, but you're stuck. Well, you can often feed some of those cryptic error messages or some of those weird scenarios, weird log lines from your system, and you can actually get sometimes some help from an LLM. And if you use an LLM, you use Cursor, you use Claude Code or something to generate something. If it's self-contained, you might be okay. If you try and write a giant application, you're probably going to be that guy in the lower right corner. But let's define debugging, just for the sake of this talk at least. We're going to say that debugging is all about locating, understanding, and resolving the causes, the root causes maybe, of unexpected or incorrect behavior. And we're going to figure this out. It's a mystery, right? Oftentimes people say it's like a murder mystery where you're both the detective and the killer, right? A lot of times these are self-inflicted wounds here that we're dealing with, right? So we're going to gather the evidence from the system itself, and observability tools can help us do that. They can give us those signals. And the classic pillars are logs, metrics, and traces, of course. And we're going to talk a little bit more in the AI context about some more sorts of things around evals and agent traces supporting that. So again, yeah, the three pillars are here. What are they used for, right? We've got logs. Everybody has logs. Piles and piles of logs are always rolling in as things are running, right? Just logs filling up. Got to rotate the logs. Oh, that volume got full, and now it's broken because there's logs. There's so many logs, right? And there's companies that have made all their money initially by letting you Spelunk through the log caverns, right, and explore the dark depths of the logs. You wonder where some names come from sometimes. And now metrics, those are metrics are like numbers, like, whatever's per second and all that sort of thing, right? So, and those things can really tell you whether your application is behaving properly, whether, you got a temperature and you're sick, or whether things are good to go, right? So metrics are also important, but not everybody uses them uniformly, because that whole, what should I measure problem? A lot of times app owners aren't really sure what they should measure, but a lot of times SREs, folks at the platform level, they do know what they care about. And then traces are a way that you can actually follow the path of execution, and even across from container to container, across APIs, et cetera. And that can be really, for distributed systems like a lot of what we're dealing with, traces can be really, really useful. But what do people really use? Well, you'll see a lot of times, probably, a lot of people default to send stuff to the debug log, or printf, I'm here in the code, or whatever, right? That's like a way you see people debug when they're writing code. But when people are debugging a bigger system, a lot of times they will just go look at the logs and try and figure out what's happening. So everybody's using logs. Fewer people. Some people are using metrics effectively, setting service level objectives and things like that, and monitoring whether they're meeting those objectives of a certain amount of uptime or certain latency and things like that. And fewer people are taking advantage of tracing, I would say. But there's certainly an opportunity there. It depends, too, on your organization, your application, et cetera. And as we were mentioning, lots and lots of logs, there is kind of a paradox, and I think that was in one of the slide titles. The paradox being that more is not always better. If you just get more and more data and you don't really have a way to reason about it, whether these are logs or metrics or whatever, I think somebody said once, if you turn on all the lights, like you turned on, imagine this is the situation, you turned on all those lights. Go ahead and try and find where the front door is at that point, right? You're going to get lost in this sea of information that is not going to help you guide you to the exit. So, of course, there are some companies that are out there that will take these massive quantities of data and use lots of really, really fancy, smart data science, et cetera, to help you sort and sift through those and find patterns. That's not what this talk is about. This talk is all about, memes and pretty pictures like that. So if that doesn't suit you, the door is there. But we'll keep going. We'll go on. So, but this is what I want you to kind of take away. You see, logs was at the top before because everybody's using them. But when we start talking about AI systems, you want to think about maybe flipping the script. You're going to want to think about those underused traces are going to become very, very important, and maybe the logs a little bit less so. So when you talk about traces in terms of LLMs and LLM-powered agents, you're going to be following the reasoning paths that these agents are taking, or in a multi-agent system, how one agent, it's a supervisor, is calling sub-agents, right? Or how an LLM as a judge is doing something, or what have you. And being able to trace that as like a conversational flow or as a chain of thought reasoning will help you understand, why did this happen? Why did we give the wrong advice to the customer about what our policy was for returning the rental car? Or, right, why did our chatbot mess that up? Or why did that AI agent deposit the wrong amount of money? You want to be able to follow what exactly happened at each stage. So tracing becomes super important. Metrics you'll see come in as well, because we're going to want to figure out how these things work and how often they work. So there's measurable numbers involved as well. And logs are still there. They're still important. We're going to want to correlate them, but they're just not as important as they used to. So here's kind of in one shot, kind of a way of thinking about some of these things. And you'll notice I do have the word evals in here. I've used the word a couple times so far. How many folks are real familiar with evals at this point? Okay, cool. So evals or evaluations, or LLM evaluations or agent evaluations. You hear these words synonymously a lot, but evals for short. And if you use evals, everyone's like, oh, they know what they're talking. They know evals. They know, they call them by the first name. So let's back into evals really quick. So first, we'll just talk a little bit about agents. This is the classic diagram from Anthropic when they first dropped their blog post on agents. They're really simple. I mean, we've all done the first part where a human, you talk to an LLM, right, in the chat GPT interface or a Claude desktop interface or whatever, and you ask, you give it a prompt, and you get back something. You get back a response. Maybe it's hallucinations, right? Maybe it's not up to date. It doesn't know the weather, in London because, it doesn't know the weather today because it was trained in November 2024 or whatever its cutoff date was. But we've added tools, right? So all these LLMs are tool capable now. So now you can provide it with a set of tools, which is software that it can ask to be run. And you can say, hey, could you please run this function for me with these arguments and then give me the results back? Because I'm a brain in a jar that was trained a year ago and I don't know anything about the outside world, right? I need help. And so through that, it can take action and do something in the environment, get information, maybe even affect the environment. Maybe we're allowing it to actually do something like control your computer, right? Computer use agents. Or we're allowing it to send an email, or we're allowing it to book a ticket for you, or just look something up. And then you get feedback, and then the LLM can use that to potentially, if it's not done yet, if it hasn't completed its task, its ultimate task, it can do that in a loop until it has completed the task that was set for it, and then stop. So this is the agentic loop. Well, and you can imagine if there were if one of those actions it took was calling another agent, right? Subbing out and saying, like, delegating, hey, you go do that. You're the expert on the weather. While you do that, I'm going to go, look up restaurants, and then I'll come back with a comprehensive itinerary for the person who wants to know what to do in London on a given evening. So we want to know, how often does this work? Like, when we put a question like that to our system, does it work every time perfectly? How often does that work? Well, you need a way to measure that. And we're used to doing things like testing. Everybody has written a test in software, a unit test, and usually things are deterministic. They run the same every time, and so with certain inputs, something will either pass or fail. But we have chosen, those of us in this room have chosen to work with these LLMs, which are not deterministic. They are stochastic, they have randomness, they come up with the craziest things, they hallucinate things, and they don't answer the same way twice, oftentimes. And that sometimes is a feature because sometimes you want them to have some creativity in what they're trying to do, but we also need to have some sense that it's doing what we want them to do. So here's an example where we might have a whole bunch of questions we want these LLMs to successfully handle. Maybe it's a customer service situation or something like that. And this is an agent that can just, I can call and it'll answer these questions successfully. Well, maybe we take a set of these questions and we take a subset of them, and then we have the LLM go through them, and well, this time it got 76% right, this time 85% right, this one 89% right. So kind of on average, speaking very loosely, it's right about 82% of the time. And then we could decide, because it's not going to be the same every time, right? It's just you do many trials, and then you see, how does it do? And in this case, then you could say, well, is that good enough for our application? Like to where, if it gets it right 82% of the time, and only 18% of the time the human gets frustrated and then asks for, a human operator, then this might be a really successful system. And then, in fact, 82% is often judged, very high. If you're over 50%, often you're doing great. So that's what evals are about. And you can see that's kind of a pseudo formula up there, but it's really, certain factors are really important. Like the model, you've got there to the power of the model up there, meaning the model has a big influence. A really quality model, as we know, will do much better. And then making sure you have the right tools available for the LLM to ask for those certain functions you want run. and then the way you set it up with its like system prompt, like its initial orientation and all that sort of thing. Here's an example of some tracing happening in a particular interface, and that smiley face is just, so I hope you have a nice day. And here you can see kind of that chain of reasoning going back and forth as the LLM is pondering the initial request and then reasoning about it. And then you might have some other tracing happening in the background that is maybe talking about some other parts of the system. So then there's a whole nother, you should go, if you're interested in this topic, which you need to be if you're going to be doing engineering or product management in this space. A lot of people are teaching courses. You can find resources on how to take and follow through what an LLM did. First, write some evals to see if it's doing basically the right thing. Then watch this thing work in the wild. And then when you find things it's doing wrong, it's making errors, you can find places where you write new evals. So now you can test those new scenarios where it's getting them wrong, and then you can tweak those variables of changing the prompt or changing the tools until you can see how you're improving the performance of the LLM. Again, that's like a very big field, but I'm just touching on it now. So takeaway number one, contrary to what my first slide said, observability is definitely not dead, but remember, if you're using LLMs, you're doing AI applications, you might want to flip that script, and otherwise you'll drown in a sea of logs and bad behavior. So then I'm going to briefly touch on kind of a new toolbox for thinking about these things. So here's a few of the agent frameworks that are out there. Chances are, if you go to implement something like that, you might use one of these frameworks, unless you're Andrew Ng, and then he says stuff like this, you know, you can use a framework or not. He's like, I'll just roll my own. He's been doing this so long. Deep learning AI, check him out. Andrew Ng is the godfather. You should check him out. But we're not just talking about agent frameworks like you see here on the top. There's other sorts of frameworks that you might be using in your applications. Like, certainly you're going to be using something for your infrastructure. You might be using Kubernetes or Docker. You might be using a more upstart like Dagger that's out there. Or you might be thinking about durable execution in the middle there. So, right, you have a process that even if it's interrupted, you want that bank wire to happen, right? Even if something happens, the network cuts, you want the system to remember and to make sure that gets finished at the end of the day. Same thing, there will be advantages to using some of these different platforms, these different frameworks. They're going to give you certain things right out of the box that make it much easier for you. And I haven't got the whole CNCF landscape. Who's seen the CNCF landscape at this point? Oh, if you're new, you got to check that out. Look, just type in CNCF landscape. You're going to see the biggest set of icons maybe you've ever seen, and it's all the kind of stuff that we deal with here at KubeCon. But I'll show you a smaller landscape on the right there. That's a really fun one from Patrick Dubois, who is, again, kind of the founder of or the coiner of the term DevOps, if you've heard that term at all. But he has really pivoted into AI. And this is a really interesting landscape that he has created for AI tools. And I just have a little snapshot of it there, and you'll notice that a lot of these tools that are in the right side there are for evaluations, for evals. And you'll notice he put them under the observability category. So, is it the case that evals are the new observability for AI? Maybe, I don't know. I'm feeling vindicated. I feel like maybe I wasn't wrong in one of my 3 talk titles. I don't know. You decide. And so takeaway for this section, a little shorter than the last one, you need observability of the whole application, the whole stack, right? But not everyone in the team needs to see it all. The product manager is going to care a lot about the evals at the top, the actual behavior of the system. And other people are going to need to know about exactly the throughput of the system or the uptime of a system or what have you. So depending on your role. And there are a lot of new tools out there for AI in particular. All right, and now the last and shortest section, rewrites. Does AI change everything? Because we talked about, do we debug or do we just rebuild the thing? Well, Well, let's get into it. So anybody check out Lenny's podcast? Any fans? All right, if you're at all into product or if you're just into tech and you want to know kind of like some things behind it or some really cool interviews with people, check out Lenny's podcast. And this was one from just last month, October 26th. And this is Donji Prasanna. He's the CTO of Block. And you probably know Block. They're the folks that do Square and Cash App and a bunch of other financial, fintech kind of products, and they actually they've gone all in at Block on their own AI agent called Goose, which I played around with a bit. It's pretty cool. And so people internally use these agents to do all kinds of stuff, both programming tasks as well as the kind of thing you would think of someone like in marketing doing to build stuff. So pretty cool. And this is a bold statement. It's like, what would it look like if we did this? RM minus RF. That, if you're a Linux person, you know what that is. It's a dangerous thing, but it means delete everything. And if you say a slash there, you mean from the root of the system, delete it all. Just wipe it out, right? So what if we did that? What if we could just take an app, and every time we wanted a new feature of the app, we didn't just try and incrementally add that feature, but we just burned the whole thing down and built the whole thing all the way up from scratch. Now, there's some systems that kind of have this ethos. There's some systems out there like Nix and some other systems that like kind of think about like, how can I rebuild things exactly the same every time from nothing? Now that's different than that's already having a recipe. This is more like saying, could I ask AI to do that for me? And maybe you can, right? Maybe you can. And this, if you're really interested in observability, I would definitely check out a lot of the work of Charity Majors. Charity Majors of Honeycomb. It's a prominent observability company. I'm not plugging Honeycomb especially, but Charity's done a ton of work and knows infinitely more about this subject than I do. But this was a really great blog post that I found of hers. Disposable code is here to stay, but durable code is what runs the world. So a dichotomy between two kinds of code, because we've been kind of just talking about, do I just use AI to help me write code? But maybe there's different types of code. So if you're talking about databases, you're talking about operating systems, you're talking about some of these essential systems that we all rely on, you don't want to have AI, you don't want to have someone vibe coding that. That's something you've got to rely on like bedrock. So that's what she would call durable code, and something that you don't want to just play around with. Additionally, we've got disposable code. And all of us have probably at this point maybe used AI to say, hey, make me this website that does this, right? That kind of code, it's kind of as you move further up the stack, and that's kind of more towards the front end or further up the stack, higher up in the stack, you can probably get away with that being a more disposable kind of a thing, something that you can throw away and put another one in. A lot of people build their documentation sites today in this way, right? They've got some source documents, and then the whole document, the whole like website for your documents gets pulled together and built fresh every time, and every so often, right? Periodically, but could be done every day, every hour. So AI could definitely help there, right? We know it can write a website really, really easily. But additionally, we know that when sometimes we have a complex problem and we don't understand it, like maybe we inherited this code base that's really important in our company. We would call it durable code, but we don't understand it because the person that wrote it left like 5 years ago, and no one's quite figured it out. Everyone's afraid to touch it. It's brittle, right? And if you look at it wrong, it breaks. And so in that case, you can use AI sometimes to help you understand that alien technology that you're left with and to start moving it in the right direction. Because doing something like saying, we're going to rewrite the whole thing in Rust to make it really fast, that's a big undertaking. But maybe if you nibble away at it, think about it, structure it the right way, AI could definitely be helpful there. So the takeaway number 3 is that we're not necessarily in burn down everything mode yet and rebuild it every time, but you could benefit from thinking about things in this dichotomy of durable versus disposable. All right, so in conclusion, I'll say observability is definitely not dead, but you need to adapt it for AI if you're going to prosper. So flip the script, think about agent traces, looking at those, learn about evals. Learn about evals, learn about evals. And there are specialized tools for all these things, both for building agentic apps and for doing evals. But of course, if you're really going to run this stuff, you're not just going to run it on your laptop or on a Jupyter notebook, but you want to put it in production, you need to talk to your Kubernetes administrator, you need to talk to a lot of folks, and you need a comprehensive strategy so you know how to keep these things running and when they're broken. And some code needs to be that rock solid stuff, and some of it can come and go. But you could probably use AI to either iterate quickly on the disposable or to build up, bulk up, strengthen, or move your durable stuff to the next state it needs to be. All right, I thank you all for your attention and your fun. And again, observability for the win. Thank you so much.